Hey guys, welcome back to Modern Education. So this is a very important video for all the 11th class JEE and NEET aspirants because in this video I'm gonna show you one quick notes. Like in via this notes you can it's more like a formula sheet. Via this notes you can happily revise that complete atomic structure chapter up to JEE level. Okay, you can easily revise it, and these notes are I made it through iPad, so let me just show you. Yeah, so this is the notes. You can see it's a very good, neat notes. Anyone can easily understand it. So I'm just gonna teach you roughly all the basic concepts, and soon I'll upload this PDF in the description down below. And in case you don't get it, in case I'm not able to upload it, then make sure you comment it down. You can comment your Gmail ID so that I can share it via Gmail. That will be much easier in case I'm not able to upload the link in the description. And make sure you like the video if you really think it's helpful, and make sure you subscribe to support our channel and even share our videos. Okay, so let's start the class. So this, as I have told you, it's atomic structure quick notes. It's going to be really helpful mainly for atomic structure because you have a lot of formulas in this chapter to be remembered. And this, I can't see it as a formula sheet because there are few important key points. Even this is also helpful for board exams. Okay, now most of the videos in YouTube I've seen it, they just gave only the formula, so it's not like that. Even you can find the key points. So let's just start it. Okay. Okay, the first one, order of E by M ratio. Many members ask this question in NEET. No, not that much in JEE. Maximum sometimes in JEE main. Order of E by M ratio. So the increasing order of E by M ratio is neutron, proton, alpha particle, and then electron. This is the order of E by M ratio. I mentioned it. Alpha is alpha particle. Cathode ray experiment. High potential, it requires high potential. I mean, that's what I mentioned everything roughly. I tried it to make it this as short as possible for you guys to understand it very easily. So you must not feel it a burden because this is a quick notes and it should not be that lengthy. High potential, 1000 volts at end of discharge start. Very low pressure. I mentioned it 10 power minus 4 at ATM. Cathode rays are negatively charged. This was done by J.J. Thomson. From Mulliken's experiment, we get these two values, electron charge and mass of electron. Then E by M ratio value, same for all gases. And then anode ray experiment, similarly I have mentioned the points. You can just read it later. And discovery of neutrons, how is it done? By bombarding beryllium and helium, and it ejects, then it forms carbon atom and ejects neutron. And then mass of proton values, mass of neutron values. Now whatever values I put it in this green box or some box, those are important. And then you can see the increasing order of masses of electron, proton, and neutron. Then 1 AMU value is 1.67 into 10 power minus 27 kg. It's very important. So these values which are in box, you must remember it. There's no other option. Okay. So those are important things, not all. Soon you'll have many things to remember. Okay. Now I've even attended many classes like Vedantu. So in that I've just taken some screenshots instead of writing. It saves time, right? So you can just go through this also. Already I've mentioned it, though you can go through it again. Next comes the Rutherford model. I've given a brief description about it. What all are important alone, I've written it. Just for a small recap before writing the exam. Let it be board, let it be J, something. Okay. The radius of nucleus, radius of atom. Mention. Radius of nucleus is equal to R naught into A1 by 3. I'm sure you might know what is R naught and its value. Now you can only understand these notes after understanding the whole chapter thoroughly. Otherwise, you can't expect to learn this chapter simply by seeing the quick notes. Okay. Now, closest distance of approach. Instead of simply mentioning the Direct result, I have mentioned some four formulas. You need not remember everything. The direct result you need to remember. That's alone fine, which is the last one I mentioned here. Okay. And if you don't know what is K, Z1, Z2, even those things you can see here, I've mentioned it here. So you need not to worry at all. Oh, just a sec. Where were we? Yeah, here. Okay. Now Maxwell's electromagnetic theory. You can just read these points. I'm sure you'll immediately get recalled of the Maxwell electromagnetic theory if you had studied it. Then characteristics of wave, the basic three formulas. It's given here. C value 3 into 10 power 8. You need to remember it. Electromagnetic spectrum. All these values you need to remember it. You can just zoom it. Just a sec. I'll zoom it a bit so you can understand it. Okay, I'm sure it's fine. Yes. Mm. So you need to remember the wavelengths, the frequencies of gamma rays, X-rays, UV, IR, radio, and the wavelength increases in the following order. Let me highlight it. This one is a must to remember. Okay, this one, which I've circled it. Next, light has dual nature. Direct question in NEET, it can easily come. Wave nature, particle nature. What is continuous, what is not continuous? Mention. Black body radiation. A simple graph I have drawn it. I'm sure this graph is taught to you all while reading the chapter. You can easily understand it. Planck's quantum theory. Main thing you need to understand is the second point. Each such packet of energy is called quantum. I mean the first point. Radiant energy is emitted or absorbed not continuously. Main thing. Not continuously. Just not continuously, but discontinuously in the form of small discrete packets of energy. Then the formula E equal to H mu, one of the most important formula for energy. Many questions can directly from through this. H value I've given it, Planck's constant, total energy, NH mu, one Einstein of energy, NaH mu. Most of them might have not learned this, so I have highlighted it. You can go through it. One electron volt charge on, and I've also mentioned the electron volt because you can't just remember one value. They'll ask you to convert to this unit also. So in joule to electron volt you can convert it. One electron volt equal to 1.602 into 10 power minus 19 joules. Just remember the order, mainly 10 power minus 19 joules. Then Vibgyor, the rainbow colors, wavelength increases as you go from violet to red. If wavelength increases, energy decreases. You all know that. As it's inversely proportional. Energy of quantum E equals to 1244 Now this is a trick actually. It's a trick. You won't find this formula. It's just a trick. You can, instead of that HC, it's just simplified. That's all. It's a trick, okay? I'm just erasing it. Even you can use that Hc by lambda. That's no issues. This is just that in electron volt. That was in joules. If you had taken the H Planck's constant in this joule per second. Photoelectric effect. It is a particle nature of light. Okay. Threshold frequency. It is one work function. All these you might have known. Just for revision. Okay. Next, kinetic energy of ejected electron. You can look at this important formula, h mu equal to work function plus half mv square, where work function is h mu, not this thing. What all are important, I just put it in a box, so it'll be easy for you to understand. One electron volt, I've already mentioned the value. Now there are two cases. P1 equal to Q1 and Q2 are alike charges. First case, Q1 and Q2 are dislike charges. Second case. So if alike charges, this is the case. R reduces, P increases, stability reduces. That's the case. If not, there's the different case. Next, Bohr model of atom. Important formula, mv square by r equal to kze square by r square. K value mention, everything. Then delta equal to hc by lambda, mvr equal to nh by 2 pi. Then radius of Bohr orbit, first formula. Then simplified formula is also mentioned. Everything is mentioned. Only the important ones. Velocity of electron in Bohr orbit given. You need not to remember all these formulas, just for the ratio. These constants, all things, you can just eliminate it. After eliminating only, they just got this main, right? By putting the value of k, e and n, we get this thing is important to remember. 2.18 into 10 power 6 into z by n meter per second. Now, now many members get confused in these coming 3 points. Now if you say ground state, first energy level, first orbit or first shell, then you need to take n value as 1. First excited state means generally many members take n as 1, but it's wrong. Ground state means n is 1. First excited state means n is equal to 2. Second excited, n equal to 3. If you say first energy, then n equal to 1. First excited, n equal to 2. That's all you need to remember. Energy of electron, K equal to kZe square by 2r. Potential energy, minus kZe square by r. And I've given the relation between Pe and Te, which is kinetic energy, potential energy, and total energy. You can find it. Now the most important, I have mentioned 4 stars, that one. E equals to minus 13.6 into z square by n square. This is a very important formula, like hc by lambda for energy. This is also one important formula. They'll ask the ratio of this energy and this energy, and what is the ratio of atomic number. They can ask like that. And these are some important conversions into kilojoule per mole, and kilocalorie per mole. 1 electron volt per atom, by atom we know to convert into joule per atom. We know electron volt can be converted to joule, 1.6 into 10 power minus 19. That one we know. Now into kilojoule per mole and kilocalorie per mole. 1 calorie equal to 4.18 joule. Now for hydrogen atom, Z equal to 1, N equal to 1, so minus 13.6. Then second one, third one, fourth shell, like that. You need to remember these. These are basic things to remember. Though you can find them, if you remember, you can do the calculations fastly. Now, as I said, I've attended few lectures, so those important things I've taken screenshot instead of writing them down. So hope you can understand these. Rydberg's equation, constant, mention the value, formula, important formula given in box. Then Lyman series, Balmer series, all the line series, n1 value, n2 value. I have again taken the screenshot. Okay. Then comes the Lyman series. Regarding Lyman series and Balmer series, little depth I just went. First line means n1 equal to 1, n2 equal to 2. First line means. Second line means n1 equal to 1, n2 equal to 3. Like that. Hope you know all those things. So just to tell what is first line and second line, I have used it in Lyman series. You can take any example, that's no fine. That's no problem. Okay, number of spectral lines formula. I've given it. De Broglie wavelength, very important formula mentioned. According to Bohr, MVR equal to NH by 2 pi. Okay. According to De Broglie, pi lambda equal to H by MV. So after equating those both, we get n lambda equal to 2 pi r. So number of waves. So n is number, and lambda is wavelength of one length. So we can say number of waves equals to number of orbit, 2 pi r, length of the orbit. So uncertainty principle, the last concept. Now I've didn't take the, you can ask that psi, those all full of graphs, that Schrodinger equation, all those things I didn't. Only that one concept I missed to include. That's of J advanced level. For J main you need not to worry it. Okay, those just are graphs, so you can study it from the book, and quick notes won't help that much in that thing because that automatically you just need to study the graphs. Now, uncertainty principle. Direct questions can be asked. Delta x. I'm sure you know delta x. What is it? The distance. And delta p, momentum, greater or equal to h by 4 pi. Delta p equal to m into delta v. All it's mentioned. Can't be mass can't change, right? So m into delta v. So that's all, guys. We have successfully completed. Hope you understand everything. I just went roughly to describe these notes. These are really wonderful. You once you go through them whole till J main level, it's cleared. Like the whole revision is done. Easy. It'll just in 10-15 minutes you can go through everything, but even remembering everything. Just in 10-15 minutes you can remember everything also. So hope you like the notes, and I said, right, if it's possible to get this MS1 notes link in the description, I will surely do it. If not, if I can't do it, then make sure you you know you can comment down with your Gmail IDs. Only then I'll be able to share it to you in via Gmail. If you really want these notes, you can do that thing. And make sure you like the video and subscribe the video. Share our videos. It would really be helpful for us. Please, by that small way, you can support our channel. So hope you like the video. Hope you love the notes. Hope it's going to be very helpful for you. So soon, if we reach more views and more likes by your support, we will definitely, based on your comments, based on your recommendation, we can definitely take another chapter and make quick notes of it in the similar way in my iPad MS Notes, and I'll share the link, the PDF, in the description. So it's just based on your support we can, proceed. So thank you guys. Hope you love the video. Hope you love the notes. So see you later. Bye bye.